Hello guys, and welcome back to the course. In today's lesson, we are going to check on the concept of end behavior together with two other concepts, which are horizontal and vertical asymptotes. So, off we go. The end behavior of a function refers to how functions behave as the independent variable increases or decreases without bound. In other words, we are trying to see the tendency of the function as we move towards the right or towards the left indefinitely. The notation for determining the end behavior of a function as x increases without bound is the limit when x goes to infinity of f of x. Analogously, the notation for determining the end behavior of the function as x decreases without bound is the limit when x goes to minus infinity of f of x. Let us consider the following graph. As we can notice, if x decreases without bound, the tendency of this function is towards the value y equals 2. So the limit when x goes to minus infinity of f of x is equal to. Now, if x increases without bound, y also increases without bound. So in this case, we say that the limit when x goes to infinity of f of x is equal infinity. Now, if we take the limit when x goes to infinity or minus infinity, meaning x is increasing and decreasing without bound, then y is also decreasing without bound. So both limits are equal to minus infinity. So that will be the end behavior for this function as x increases without bound and also as x decreases without bound. Now let us consider the following periodic function. This function is oscillating between -1 and 1. So for us, it's impossible to determine one specific value for which this function has the tendency to go to, both as x increases without bound or x decreases without bound. Thus, we say that this function does not have an end behavior. And the notation for describing this is the following. The limit when x goes to infinity of f of x does not exist, and the limit when x goes to minus infinity of f of x does not exist. Now, if the end behavior of a function exists and is equal to a finite amount, then we say that such a value represents a horizontal asymptote for the function. For example, if we consider this graph, then we can notice that the end behavior as x increases without bound, meaning the limit when x goes to infinity of the function, is equal to 3. Then 3 represents a horizontal asymptote for the function. Now, we just learned the concept of horizontal asymptote. Now, as there is a concept for this, there's also a concept for vertical asymptote. We say that a vertical line x equal k represents a vertical asymptote for the function f of x if and only if the following conditions are satisfied. The first one is that the function is not defined at x equal k. And the second one is that as the values of x approach to the value x equal k, the values of y increase or decrease without bound. Well guys, that's all for today. Thank you very much for following the video until its very end. As usual, it's time for you to put your knowledge into practice by doing the following problems. And well, as usual, see you in the next lesson.